All right, we're looking at page 8 in the packet, specifically discussion questions 16 and 17 here. So what I want you to do is just take a minute and see if you can answer those questions, okay? Start with number 16. It asks, does it reverse directions of motion? Does it start and end at the same spot? It asks you a few questions. Go ahead if you see if you can answer those. Take a pause and then come back and we will go through it. All right, so number 16 is a position versus time graph. So I'm using those understandings that the point on there is telling me about the position, the slope is telling me about the velocity, and the concavity is telling me about the acceleration. So part A asked me, does it reverse directions of motion? So motion is really talking about velocity. So does the velocity switch directions? And so what that's asking me is, if you look at the graph, velocity is the slope. So it's asking me, does the slope ever switch directions or sign? So does it ever switch from a positive sine slope to a negative sine slope? And yes, it does. For the first part here, it has a positive slope, 0, and then a negative slope. So yes, it does switch directions. So we'll put a yes next to that one. Part B, does it start and end at the same spot? So I'm looking at position. So it's position versus time graph. So it starts at a position of 0, goes out some positive distance, and then comes back to that same position it started at. So yes, that one is also a yes. It does start and end at the same spot. Constant velocity. So when they ask for a constant velocity, they're asking, is the slope constant? Does the slope stay the same? Nope, the slope is positive, 0, then negative, so no. Then ask me, does the speed ever reach 0? So speed is just asking me how steep it is. It doesn't care if it's a positive or a negative, it just cares about how steep is it. So is its steepness ever 0? Is the slope ever 0? Yes, for one small point right there at the top, when it switches from a positive number slope to a negative number slope, it's got to go through 0. So yes, for just a split fraction of a second, for an instant in time, it does stop. E asks, is there an acceleration? So basically it's asking, is there concavity, and is my curve curved? Yes, it's curved and it's concave down, and so that means I have a negative acceleration. So here is a yes again. All right, if you haven't done so already, go ahead and try and answer the 4 parts to number 17, and then I'll walk you through those. All right, number 17, first one up there asks, does it reverse direction of motion? Now I'm looking at a velocity versus time graph here. So I'm seeing, does the velocity ever switch directions? So is the velocity ever a positive number, then a negative number? So does the graph ever switch from above the axis to below it? Starts at 0, positive velocity, positive velocity, positive velocity, 0. Never goes below, so no, it does not switch directions. So that's a big no there. All right. Does it return to its starting point? If you return to your starting point, if you start at one spot, go somewhere and come back, your displacement should be 0. And when I look at a velocity versus time graph, displacement is determined by the area under the curve. And so if I look at this one, I see that that area under the curve here is above the axis, so it's a positive area. So this has a positive displacement. So the answer would be no, it does not return to its starting point. All right. Does the speed ever reach 0? So is my velocity ever 0 at any point? Yes, right here at the start and right here at the end. So yes, the speed does reach 0. Oops. That is a yes. All right. And then the last one is the acceleration. Is there an acceleration? Yes, I'm looking for slope on a velocity versus time graph. So the slope is positive, 0, negative. So the acceleration was positive, negative. I'm sorry, it was positive, 0, and then negative. So there you go. So that was a yes, it does have acceleration. All right.